Okay, it's starting to record now. Okay. So I will start with question number 7 on the tutorial sheet, right? Okay, guys. So let me change the camera, which is here over here. Oh. Here we are. Hope you can see this. Let me know if it's not sharp enough. I will try to adjust the camera so that you can see it better. Right. So this is question 7 on the tutorial sheet. Here you're given the CDF, which is equal to 1 minus 1 plus x divided by lambda to the power minus alpha, where x is positive. So the question is to find the var and es, right? So to find the var, as you know, I mean, we have done enough examples on this. You should know what to do. To find the var, what you need to do is to set the CDF equal to p and solve for x in terms of p, right? Can you hear me well now? Let me increase the sound in case you have problems hearing me, right? All right, so this implies that equal to this, yeah? So this implies that yeah, and this implies that 1 plus x by lambda is equal to this, right? So hence your x is gonna be lambda in brackets right? So hence the expression for var is equal to this, right? Which is lambda times 1 minus p yeah. So that's the expression for var. Now to find the expected shortfall, ES, you will use this formula I gave you earlier. All right. So if you use this, you get lambda by p. Lambda is a constant, so you can pull it outside. So inside the integral, you'll have this, right? Okay, guys. Excuse me. Right. So now the integration of this is not difficult. So if you integrate this with respect to t, you get this, right? And after taking the limit at p and the limit at 0, the final answer you will get is the following, unless I made a mistake. All right, so this is the answer to question 7. You okay with that, guys, or not? Hello, guys. You have any questions? Let me know. Thank you, Lee. All right, the next question is question 8. So if you're okay with this, let me take this away. Question 8 is the following. You have the CDF f of x equal to this, where x is positive, right? And we want to find the var. Okay, in order to find the var, you set f of x equal to p, right? And this implies that equal to p, right? Taking the logs on both sides and multiplying by minus, you get sigma by x to the power alpha equal to this, right? So sigma by x is equal to minus of log of p to the power 1 over alpha. So your x is going to be sigma right? So hence the expression for the var is equal to okay. You okay, guys? Okay, now to find the expected shortfall, you will use this formula. Sigma is a constant, so you can pull it outside. So sigma by p times the integral of minus log of t to the power minus 1 over alpha dt. All right, now to do this integration, you will need some substitution. I mean, as I said before, I mean, there's no rule for what substitution to make, right? And it's something that you have to learn. It's something that you have to learn by experience. So in this case, the substitution that will work is the following. because you have this minus log of t, one substitution that will work is to set y equal to minus log of t, right? Okay, so that implies that t is equal to e of minus y, all right? So dt by dy is minus of e of minus y, right? So let me put this in a box as usual. Okay. All right, guys. So I'm gonna now make the substitution into the integrand. So let's see what we will get. Excuse me. So if you do the substitution, first of all, you have to take care of the limits. When t is 0, right? When t is 0, y will be plus infinity, right? And when t is p, y will be minus log of p, right? So inside you will get y, right? And dt by dy is minus of e of minus y dy. Okay. All right. Now I'm going to use this. I'm going to use this minus sign to change the limits around. Right. So you know that you can, when you multiply the integral by a negative, the limits change around, right? So this guy here will become okay. Right. Now I'm sure I mean, I did a video in the preliminary section on the gamma function. I think you probably remember it. If you don't remember it, please go to the preliminary section and listen to the video on the gamma function. For the gamma function, the integrand is something like this, but the limits of integration are from 0 to infinity, not this to infinity, right? So what you have here, right? Let me take this on a fresh page. Excuse me. What you have here, guys, is an incomplete version of a gamma function. When I say incomplete, I mean instead of from 0 to infinity, you have a fixed number up to infinity. And this is known as, all right, before I write it down, let me give you the definition of what I'm looking for. There's something called the incomplete gamma function, which is defined as, instead of going from 0, it goes from a fixed number to infinity of t dt, right? And this is known as the lower incomplete gamma function. The word lower means because it corresponds to the lower limit. Sorry. How do you know you can't see it? Sorry. So the lower means it refers to the lower limit. So it's the version of the gamma function. The only difference is that the lower limit is not 0. All right. So let me put this once again. All right. Once again in a box. right? Okay, so using this definition, right, this integral here can be written as follows. Your a is 1 minus 1 over alpha, right? And your x is gonna be this guy here, right, which is minus. Okay, so that completes question 8. Okay, any questions, guys, on this? Hello, guys, talk to me. Are you okay with this or not? Okay, thank you. All right, the next question I'm going to do is question 9, right? So this is question 9. So here the CDF equal to is equal to this, right? Where once again x is positive, right? So to find the value at risk, you set this, right? Which implies that is equal to this, right? Which implies that it's equal to this, yeah. So this implies that this is equal to this, yeah. So finally, your x is gonna be equal to sigma times right. So your expression for bar okay. So this is the expression for value. You do this, yeah. Right, you use this formula, which is gonna be sigma is a constant, so you can pull it outside. So sigma by t, and then you have right. All right, now once again to integrate this, you will need a substitution, right? In this case, the natural substitution to make is to set y equal to minus log of 1 minus t, yeah. So this implies that 1 minus t is equal to e of minus y, right? So your t is 1 minus this, yeah, and your dt by dy is e of minus y. Okay, so let me put this in the box. Okay. Okay, so now I'm gonna substitute this into this, right? So you will get the following: sigma by p outside. All right, the first thing to do is to take the limits. When you put t equal to 0 into this, you get minus log of 1 minus 0, which is 0. All right. When you put t equal to p into this, you get okay, and then you have y. Okay, you have this, right? Now this integral is also known as the incomplete gamma function. The difference between this and the gamma function is that the upper limit is not infinity. The lower limit is 0, but the upper limit is not. And there is a term for this kind of integrals, which I will introduce in the next page. The definition for this kind of integral is, well, the notation is this. It uses the little gamma, not the capital gamma. It uses the little gamma with two arguments, a and x, and is defined as the integral from 0 to x. X is a fixed number of okay, and the term for this function is the upper incomplete gamma function. The term upper refers to the upper limit, because as you know, in the usual gamma function, the upper limit is infinity, 0 to infinity. But here you're going from 0 to a fixed number, x. So hence the term upper, right? So this is the definition I'm going to use. I'm going to use to do the next step, or the final step, right? Okay, so using this definition, we can write that as follows: sigma by p times the upper incomplete gamma function. At your a is gonna be 1 plus 1 over alpha, and your x is the upper limit, right, which is minus all right. So that completes question 9. Any questions on this, guys? Are you okay, guys, on this? Hello, you okay? You guys okay with this? Okay, thank you. Thank you, guys. All right, the next question the next question is question 10. So here the CDF is the given by this expression here. Yeah, and this is known as the generalized Pareto distribution. I think we talked about this distribution a long time ago. You may when we talked about definition 2 of extreme values, this came about. To find the var, we set this to p, so this becomes 1 minus okay. So this implies that it's equal to 1 minus p. All right. Excuse me, sorry. So this implies that okay. So all right, so your x is gonna be k over c in brackets 1 minus p power c. All right, so your expression for var is equal to this, right? All right, now to find the expected shortfall, we use this formula. The formula is var t, this should be t, it should be x d2. So the k is a constant, c is a constant, so you can pull them outside, so it will be k okay. Now this integral is not difficult, so you don't need any substitution to do this integration. So it's pretty straightforward. So you need to divide also by -1 because of this. All right, then you take the limits from 0 to p, and the final answer is correct me if I'm wrong. This is what I'm getting. Right. Okay, so this is the expression for expected shortfall, right? All right, guys. Okay, now, okay, so this is question 10. All right, the next one is question 11. In this question, what you are given is the quantile function. What you are given is a quantile function. I hope you guys know what a quantile function is from previous courses. I mean, a quantile function is basically f in, this is what is known as the quantile. This is what is known as the quantile function, right? It's basically this inverse of the CDF at P. But this, as we know, this is the definition of var also, right? So the question 11, question 12, and question 13, because they give you the quantile function, they give you the expression for var, right? So in question 11, the var is the same as the quantile function, as you know, is equal to all right, so the var is already given to you. So the only thing you need to work out is the expected shortfall. So to find the expected shortfall, you just use the formula that you know, okay? Right, so this is gonna be 1 over P lambda 0 to P okay. Now integral of this is not difficult, right? So you get 1 over P lambda T all right? Then you take the limits from 0 to P, right? And if you do that and simplify, you get this, unless I made a mistake, let me know. Okay. All right, guys, are you okay with this? So the question gives you the quantile function. So the quantile function by definition is also the expression for var, okay? So basically, all you need to do is to work out the expected shortfall, right? Okay, so that's question 11. Question 12. Question 12 is this. Here you are given the quantile function. The quantile function is given to be Yeah. So this, by definition, is the same as the value at risk. Okay. So this is also equal to okay. All right, guys. So all you have to do is to just work out the expected shortfall. Which is delta is a constant. So you integrate from 0 to p of this. All right, and once again, this integral is not difficult to do. So you get integral of this is t right, take the limits. So after taking the limits and simplifying things, you get this. Okay, so correct me if that is not correct, right? I hope it is correct. Okay. So that's the answer to question 12. And finally, question 13. Are you guys okay so far? I mean, anything, any question, anything you want to ask, please feel free. Use the chat box or talk to me using your phone. All right, so this is the final question, is question 13. So here, the quantile function is equal to the c, which is a constant. Yeah. So therefore, the var, the expression for var is also the same. All right, now to find the expected shortfall, you use the formula. Okay, so you can pull the constant c outside, divided by p, integral from 0 to p of t power alpha divided by 1 minus t power beta dt. Okay, so this is c divided by p. This is p, guys, of the integral from 0 to p of t power alpha 1 minus t power minus beta dt. Now, I think I mentioned this integral before in the class. In case you forgot, let me write it down again. There is something known as this. This is the notation. This is known as the incomplete. Remember, the beta function is integrated from 0 to 1 of this integrand. Right now, the difference here is that instead of integrating from 0 to 1, we integrate from 0 to a fixed number x, and this function is known as the incomplete beta beta function. The incomplete refers to the upper limit. Instead of it being 1, it is a fixed number x, which is a number between 0 and 1. All right. Anyway, I think I mentioned this before in some time ago, but if you forgot, I just wrote down. Okay. So using this definition, you can write the above as follows. So it will be C divided by P, the incomplete beta function. Your X is P, and your A is 1 plus alpha, and your B will be 1 minus beta. All right. So this is the expression for the expected shortfall. All right, guys. So this completes the tutorial sheet. As you know, next Tuesday you have two assessments. One is the I mean, I know some of you may think I'm giving too much work for you, but I think, you know, you learn. I mean, the reason I'm giving these quizzes is because you kind of understand what I'm teaching every day. I mean, every week. I mean, so that's why I give you all the quizzes every weekly. And as you know, I mark all of them on the same day and give them back to you so that you understand wherever, if you made a mistake, then you know where you made a mistake. So anyway, the next Tuesday we will have two things you need to do. One is you need to submit the quiz, the next quiz, which is quiz number 6, right? Which is really not difficult. I mean, quiz number 6 is basically computing var and es. I mean, we have done enough examples already, so you shouldn't have problems doing quiz 6. It's just computing. I mean, we have done plenty of examples. I mean, and then you have the test, which is from 4 to 4:30 p.m. UK time. I know some of you are not in the UK, so make sure you follow the UK time from 4 to 4:30 p.m. right? And you should email me your answers before 4:45 p.m. right, UK time. I will mark all of them on the same day, and I will let you know what you got for the test, and also I will let you know what you got for the quiz 6. Okay. All right, guys. You have any questions? I mean, now, I mean, you cannot. You have only like 3 days left or 4 days left now. I mean, you can please try to contact me 24/7 by email or by Skype or by Zoom or in person. I'm also happy to see you in person if you are in Manchester 24/7. As I said before, I am very close to the university. I live very close to the uni, so I'm happy to meet you in person if you have any problems you'd like me to go through. Okay. All right, guys. Are you okay now? You have any questions right now, guys? please feel free, please feel free to contact me. Okay, thank you guys. All right. So I mean, for the test next Tuesday, I mean, there are many example questions and solutions on the course website. So if you go to the course website, you see there are at least about more than 10 different examples on how to do the on the kind of question that you will get in the test on Tuesday next week. So you should practice all of them. You should be fine. I mean, just if you practice all the questions on the website, then you should be fine for the test next week. All right. But of course, if you have questions, you can. I mean, please don't feel that you are disturbing me even during the weekend. I mean, you can contact me 24/7 anytime, by any means. All right. Just I will try to help you as much as I can. Okay. All right, guys. So have a good day or good evening, and I'll talk to you soon. All right. Okay.